Hello everybody, and welcome to lesson 10 of using Python and Blender to create this more advanced tank model. So, in the last lesson, you remember that we started animating this tank imploding, um, but because of negative pressure, the tank implodes like that, even though it's really laggy. But you get what I mean, right? Okay, and now we're going to do make some changes to the implosion, because, you know, even though it's better than before when it was just like squeezing on itself, collapsing, falling through the floors and stuff, even though it's more realistic than that, it's still not that realistic, because in real life, if a tank's imploding, then you wouldn't expect it to, like, evenly implode, it's doing over here, like the same parts imploding. You wouldn't expect it to do that, because that's like my FPS is 0.96. Yeah, you wouldn't expect it to be that. So you would expect, like, some parts to implode more than others, those kinds of things. And that's exactly what we're going to do today. So let's go to scripting. I added some comments, but the code is exactly the same as last time. I just added some comments, and I just changed this a bit. I put an enter on this. It used to be a one line, but I put an enter in there. But other than that, it's the same, and none of the code changed. Stay the same code, just more comments, and the pin vertices state changed. So to do that, we need to pin more of the points. Pin more of the points we added, because right now we only pin the edges, the points in the edges over here, and that's not enough. We need to pin some parts over here to make it seem more realistic. So to do that, let's create a new vertex group. So then we're gonna name that, wait, have to. And we're gonna name that target vertices, and v.index for v in Russell.data.vertices if. So now here you can just continue typing like this like we did last time, or you can just do this. It doesn't really matter. v.co.z bigger or equal to -0.5, and v.z is smaller or equal to 0.5. Oops, smaller or equal to 0.5. And v.co.y is smaller than 0.2. So if you look at the v.coordinates, the z part first, you can see it's kind of the opposite of this. So here it needs to be either negative 0.5 or larger than 0.5. But this time we're just doing the opposite. So we're doing that because, well, you don't want the edges, so we're just like removing all of the edges because we don't want them. And also to the points on the edges. And oh, it's 0.5, not 0.4. And it's because, well, If it's or, then if it just only meets one of the requirements, then it could still be with the other edges. And when we're using a the random import we did last lesson to create this. So that's why we need these requirements. What about this last part? That the vertex coordinates has to be smaller than -0.2. Well, we add that because those are the points like in the middle of the sides facing you. The y coordinate going this way, so they're the middle of the side parts. So we don't want those either. All right. So now that we've defined what requirements we want, now we can use a random number thing to randomly pin some vertices. So number of we're gonna call those seeds. 2. So we gotta choose 2 random points to pin. Seeds equals random dot sample target vertices number of seeds. So 2 of the random 2 numbers that meet the requirements over here. Then radius is equal to 0.5. Radius 0.5. That means that if we choose random points and if they're within 0.5, then they can be caving in. So I explained it wrong. It's actually the reverse of what I just said. If it's within 0.5, it takes 2 seeds where it does cave in, and then the rest don't cave in. Okay, but now that we've defined that, we have to do something so that we can actually like replace the points like we did over here. So how do we do that? Well, I'll just modify this for loop over here. So else w is still equals 1.0, but then we add another for loop for s in seeds. Okay, and this 0.0 is still going to be in here. D is equal to v the coordinates minus verts s the coordinates dot length, and then we're actually going to do this again because we would have an if over here. If d is smaller than radius, then it's going to be equal to 0.0 break. Okay, so basically what we did is that we should start with our base mass over here, kind of, and then if we're in the seed's radius, which is like these two, then we just keep checking if it's the seed's radius. If it is, then the weight's 0.0, and then you just break if you find one. So yeah, that's what happens. You just break once you find one smaller than radius. And then you set that to 0.0, wait that way to 0.0, then you break. That's basically what happens. So now when we run this, and actually let's set this to 300. And it's gonna take a long time to run, so I'll be back when it's done. Okay, it's done running. So you can see that's not evenly collapsing, which is our goal. It's a bit more realistic, kind of. Now we have like a space where it's going. But there's still one problem. Let's see, if you look closely, you see it's like bouncing because it's a cloth modifier. So it's like bouncing like a cloth, and that's not realistic at all. But this is an easy fix. We're just going to add some damping, which makes the cloth more damp, making it so that it moves less. Okay, so let's animate it. Not animate, let's make the settings. Class mod dot settings dot effector weights dot gravity equals 0.0. I wrote that because I accidentally deleted it last time. So yeah. But now we copy the cloth mod dot settings part, and we actually have to copy it, I think, 5 times. Let's see. Actually 6 times. Okay, yeah, it's 6 times. Sorry, I was just thinking about it. So air damping. So the default of air damping is 1.0. The max is 10. We're just setting most of them to the max. So tension damping is equal to 50.0, so just the max of every kind of damping. Bending damping is 1.0, and the max is actually 1000 for here. But however, if you make it like 1000, the animation is going to be like unstable and stuff. Compression is also the max at 50. Compression damping 50. Shear damping, I don't really know what a lot of these mean, but they're damping, and we just turn them to the max. Okay, now that we've tried this, well, you can already see it looks better from the slow point of view we see. And it's very laggy. This changes to wire. You can see it's already looking way better. There's no like, it's not like bouncing and stuff, which is good. And what we want, once we wait for it to go, we can see it more. We can see it better because it's not at 0.93 FPS right now. can see there's no jiggling. At least when it's slow. And when it goes faster, I bet there's not going to be any either. And there's not, see? It's actually, it's pretty cool on the inside. Do you see it just collapse? But you can see we minimalized the jiggling. I mean, obviously this is gonna be a little, but like, if you see from the outside, it's not as obvious as before. So that's it for today. Next up, I'm gonna do some stuff with the lighting and camera angles. Oh, bye.